After traveling 2.4 billion kilometers through space for 7 years, the OSIRIS-REx spacecraft successfully dropped off its precious cargo of asteroid sample at a NASA facility in Utah on September 24, 2023. It's the first time NASA has returned asteroid material to Earth, and scientists are already planning to use the sample to answer big questions about our solar system's history. So let us take a look at what this mission has accomplished and what we might learn from it. The OSIRIS-REx spacecraft was launched on September 8, 2016. Its target, the near-Earth asteroid Bennu. After spending 2 years cruising through space, OSIRIS-REx arrived at Bennu in December of 2018 and spent more years observing it and charting its surface. On October 20, 2020, OSIRIS-REx performed a maneuver that brought it just 1.4 kilometers above Bennu's surface, and then it did something incredible. It shot a small amount of nitrogen gas at the surface, which created a spray of rocks and dust. This is called a tumble, and the idea is that by blasting away the loose, fine-grained surface material, you expose fresh rock underneath that hasn't been seen since it was brand new. When the asteroid was forming around 4.5 billion years ago, this would allow scientists to study material from a very early stage in our solar system's history. The spacecraft flew away from Bennu soon after that to avoid being hit by any of the ejected material, which included large rocks and dust. But unfortunately, OSIRIS-REx ended up with way more material than they expected because some of it stuck to the side of the spacecraft during the maneuver. So it had to make multiple close passes of Earth's atmosphere over the next couple of years to slow down enough to come into land softly. And that brings us to September 24, 2023, when the capsule containing the asteroid sample successfully landed in the Utah desert. The entire operation was broadcast live on NASA's channel, and there were lots of people watching both at the control room and out in the desert waiting for the landing to be confirmed. There was a lot riding on this. Not only was this the first attempt to collect and return an asteroid sample, but it was also the first time NASA had tried returning a sample from deep space. And while OSIRIS-REx successfully completed its mission, the spacecraft itself didn't make it home. After dropping off the capsule, it started to lose altitude and eventually crashed into the surface of Bennu. So hopefully they got all the good stuff into the sample return capsule. In total, the sample return capsule weighed about 576 kilograms when it landed in Utah, but how much of that was actually from the asteroid? Well, we don't know yet. The plan is to slowly open the capsule over several days and measure the weight of the contents, which should give us a rough idea. But even before opening the capsule, scientists are excited about what this material can teach us. Asteroids are the leftovers from the formation of our solar system and planets. So studying them gives us a window into conditions that existed 4.5 billion years ago. They can also tell us what Earth was like before life evolved. And finally, understanding asteroids can help us prevent future impacts. Bennu in particular is exciting because it's a carbonaceous chondrite, meaning it contains a lot of carbon, and is made of chondrules, which are tiny mineral grains that formed in hot gas clouds. Carbonaceous chondrite meteorites are also rare here on Earth. So the fact that we now have a whole bunch of Bennu material to study is huge. Scientists think that carbonaceous chondrites were likely the source of the building blocks of life on Earth, and some researchers believe they themselves may have played a role in the origin of life. If that's true, then studying Bennu could tell us what conditions led to the formation of organic molecules that eventually became living things. In particular, scientists are looking forward to studying polycyclic aromatic hydrocarbons, or PAHs. These are complex organic molecules that absorb visible light and are found throughout space. We know they exist on asteroids because we see the absorption lines in our own telescopes, but we don't know where they come from. Some researchers think PAHs form when molecular hydrogen is broken apart by ultraviolet radiation from stars. Others think they form from the chemical breakdown of more complex organic molecules. And still others think PAs could be produced by living things. But either way, studying them could tell us more about the chemistry that occurred in the early solar system and whether organic molecules could have formed on their own without the help of life. And if we can figure out how PAs form, we might also be able to understand where they come from on other worlds. For example, Titan is Saturn's largest moon and the only moon in the solar system that has a substantial atmosphere. Some of the molecules in Titan's atmosphere are similar to those that make up PA, but we don't know if they ever combine to form larger structures. Studying Bennu could help us answer that question and better understand the atmospheres of other worlds. Now, not all asteroids contain organic molecules like PAHs, but Bennu isn't just special because of what it does have. It can also teach us about what happened to Earth before life evolved. For example, Bennu is thought to be an undifferentiated asteroid. That means its materials haven't separated into layers or undergone any major changes in state. In other words, it looks pretty much the same in its interior as it does on the surface. That's different from differentiated asteroids like the one that killed off most of the dinosaurs. And it turns out that Earth was once very similar to asteroids like Bennu. It was hot, molten rock, and it took millions of years for it to cool and differentiate into a solid inner core, a liquid outer core, a thick silicate mantle, and finally a crust. So studying undifferentiated asteroids like Bennu can tell us what Earth was like before it differentiated. This will be especially useful for studying the evolution of water on Earth because Bennu contains a lot of hydrated minerals, which means they have water molecules trapped inside their crystal structure. Scientists think water on Earth came from asteroids like Bennu, and studying the water in these minerals could tell us more about where it came from and how it got here. Now, asteroids aren't just remnants of the past, they can also shape our planet's future. Over the last few decades, astronomers have discovered thousands of asteroids that pass between Earth and Mars. And while there aren't any known threats in the near future, that doesn't mean we're safe forever. If we ever do need to move an asteroid away from Earth, though, we can probably thank OSIRIS-REx for helping us figure out how. The sample return capsule landed in an impact crater that was named after the spacecraft. And, ironically, that makes it perfectly placed to help us study how asteroids impact the Earth. That's because studying fragments from Bennu could tell us how strong its surface is, which is important for knowing how fast an impact would have to be to break through. And it could also tell us how much an asteroid's shape affects the damage it causes. By learning more about asteroids, we can develop strategies for moving them away from Earth. Of course, there's a lot more science left to be done. Now that the capsule has landed, scientists will spend the next year or so checking their equipment and designing experiments. Then they'll carefully open the capsule, take samples from different parts of the asteroid, and start analyzing the material. They'll also continue collecting data from Bennu itself, even though the spacecraft is gone. OSIRIS-REx left behind a CubeSat called Alex that will continue observing Bennu for at least another year. It lines monitor the asteroid's rotation and orbit and watch for any changes caused by the sample return. CubeSats are getting better and better every year, and Alex is no exception. It weighs less than 1 kilogram, and it carries a 340 megapixel camera that can observe Bennu in unprecedented detail. So the OSIRIS-REx mission isn't over yet. We've just entered a new phase. And while we wait for the results, we can be grateful that NASA brought a piece of the asteroid home. Thanks for watching this episode. I'm the host, and this has been NASA Space Place. Thanks for watching, like, and comment your thoughts. Subscribe for more videos. Till then, bye.